Hello, I am Daniel Eisenbach. I am a member of the OCR Speed Recognition Project. The purpose of this video is to outline progress that has been made to date on the project. So far, we've had about 8 weeks of development, and the most major accomplishments so far have been the block diagram, which will be discussed in this video, in addition to the current successes we've had in detecting words in images. The goal of the project is to assist in the development of autonomous trucks. And what we're doing with this project is allowing for trucks to autonomously detect speed limits and react to them on their own without driver input. And we're doing that through optical character recognition, OCR, which is a versatile way of doing this because it allows us to easily in the future branch to other speed signs that contain text such as truck weight limit or a truck specific speed limit, for example.
Hello, my name is Zachary Stark, and I will be talking about the system level design for the OCR speed sign recognition project. The general concept, the high level concept would be input through a camera of video of what the driver would normally see in a driving situation, and the frames from the video input will be processed using OCR algorithms in order to determine whether or not there is a speed sign in the frame, and then if there is, to parse out the speed limit information specific to that frame and display it to the user on the phone screen. So I'll go through a general description of how the blocks are laid out in order for this to happen. Here is the camera block. We take in video through this camera and feed it into the phone using USB camera Android open source interface software. That gets fed into a queue that'll hold these frames for processing. A frame from this queue will go into image pre-processing to get it high contrast and make it prepared for OCR algorithms to work. From there, the data will be processed in order to create a speed limit, and that will be reported to the user interface on the phone display and also submitted through Bluetooth to our PCB portion of the design, which Daniel will talk about shortly. So I'm going to give it to Daniel now.
Hello, Daniel here. So the purpose of this project is to design a system that will live in a truck, and current truck communication is primarily CAN based, controller area network. So what we're doing with our PCB requirement is we're creating a way in which we could potentially send CAN messages to the CAN network on a truck, and we're doing that via Bluetooth. So we'll use the Bluetooth transmitter in the phone, send that over to a Bluetooth receiver that lives on a PCB with its own power supply, and then that Bluetooth receiver will transmit the data to a PCB CAN transceiver, which will allow us to convert the messages from the OCR app into CAN format to be transmitted to a system on a truck or any device that can read it, such as an oscope. Now, Ryan Wood, our other team member, is going to go ahead and talk about current successes we've had with actual speed sign detection and work that we've done there. So I'm going to hand it over to him.
As Daniel mentioned, my name is Ryan Wood. Both he and I, as well as Zach, have been working on characterizing the software. The library we've been using is Tesseract. It's an open source OCR library, or engine rather, and we've been trying to figure out what it can do without any more software assistance. What can it do in its raw form? And so this is the image you saw earlier. This is actually an image that I personally have been working with to see what Tesseract can do. It does not process in this raw form. Like, it's not going to work. So there's a couple of different things you can do. This next image is an example of a pre-processed image using a couple techniques. Primarily, thresholding. That's the changes the image to be black and white and high contrast. Like you can see the speed sign, the text is very visible, much more visible than before. If we go back, you can see the difference. The other big technique is called binarization, and that's changing the number of colors that can be in the image, and that's just a further increased contrast. Beyond those two techniques, I also did some manual transformation of the image to isolate the sign. Here's an example where I just crop out the speed sign, take away, this is actually, the border gets taken away by Tesseract itself. It does some pre-processing. So this is an image that I've had some success with. We got speed limit in the number 4, not 45 necessarily. It's another try. We were thinking about chopping up the image and seeing if we can get the number out. This one, I believe, gets 45, but it also gets an L and an exclamation point. So, you know, a little funky, but better than not getting the number at all. And this is another Tesseract processed image. You can see the border gets removed. This one actually surprisingly had less success. Overall, we're figuring out what we need to do in order to make this work. But we know now that in Tesseract's raw form, we're not going to have success. So we definitely need to work on pre-processing.
Hello, this is Zach again. In conclusion, we hope that you have a better understanding of the high-level design of this project and that you understand the minor achievements that we've made in recognizing characters and speed signs. Thank you for listening.